Hello guys, this is Mr. Ala, your math teacher. I hope you are doing well. In this video, we will correct some of the exercises in your book that could summarize the whole chapter for you. I'm going to start with exercise 5, page 114. Now in exercise 5, we have ABCD, a parallelogram. I is the midpoint of CD, and A prime is the symmetric of A with respect to I. So again, ABCD, a parallelogram. I, the midpoint of DC, and A prime is the symmetric of A with respect to I. And when I say with respect to I, then I know that I is the midpoint of this segment A prime. So for now, I know that I is the midpoint of A prime, I is the midpoint of DC, and ABCD is a parallelogram. Part 1 of this exercise. Prove that A prime, C, and B are collinear. Now, to prove that 3 points are collinear, you have two ways to do so. The first one is to prove that these 3 points, let's say these 3, make a flat angle, an angle measuring 180 degrees. This is the first way. The second way is to prove that these 3 points make two lines that are parallel. Okay? Now, if you think that the first method is easier because the other one does not make sense to you, of course, how come two lines are parallel and they meet? But we will talk about that later. Here, we're not going to use this method. We're not going to even try to look for a flat angle or a 100-degree angle because he didn't give you any measurement in this exercise. You know nothing about the angles in this exercise. So this method, for now, we're not gonna use it. So we're gonna stick to this one. Form two lines using these 3 points and prove that they are parallel. Now, you have 3 points, right? A prime, C, and B. Now, to prove that, or as I said, you have to form two lines using these 3 points. The obvious choice is CA prime, this line, and BC, this one. Now, to prove that these two lines are parallel, the easiest way to do it is to prove that they are both parallel to a third line. Now, if you look at the figure, you notice that BC is parallel to this line, DA, right? Do you know why? Simply because ABCD is a parallelogram, right? So we already know that BC is parallel to AD. And my objective is to prove that CA prime parallel to BC. And as I said, the easiest way to do it is to prove that they are both parallel to the same line. So if CA prime is parallel to this one, AD, then BC and CA prime would be parallel to the same line AD. Okay? So how am I going to do it? The easiest way to prove that two lines are parallel, or one of the easiest ways to prove that two lines are parallel, is to find a parallelogram containing these two lines. Now, can you form a parallelogram using AD and CA prime? Yes, of course. This one, AC A prime and D. Now prove that this one is a parallelogram. We already said that I is the midpoint of AA prime and the midpoint of DC. So DC and AA prime bisect each other. And it happens to be DC and DC and AA prime are the diagonals of this quadrilateral. So if they bisect each other, then this quadrilateral is a parallelogram, and that's what I said. AC prime D is a parallelogram since the diagonals bisect each other. So AD would be parallel to CA prime, but AB is also parallel to BC since ABCD is a parallelogram. That's what I said before. So BC is parallel to CA prime, therefore BCA prime are collinear. Now, why are they collinear? Notice that BC and CA prime have a common point C. And I'm saying that these two lines are parallel. If they are parallel, they could be like this. But if they have a common point, then where would this line be? It would be here, right? It would be the same line as the first one. What I'm saying is, if BC is parallel to CA prime, that's only because BC and CA prime are the same line. Okay? Now, using the fact that AC prime D is a parallelogram, we know that CA prime is equal to AD. But ABCD is also a parallelogram, so BC is equal to AD also. So for now, we know that not only CA prime and BC are parallel to AD, but they are also equal to AD. So they are equal to each other. And because these 2 points are collinear, C is the midpoint of the segment BA prime.
Part 2 of this exercise. If O is the center of the parallelogram ABCD, prove that OI is 1/4 BA prime. Prove that OI is 1/4 BA prime, knowing that O is the center. And the first thing that you should know about O is that it is the midpoint of the diagonals, right guys? The center of the parallelogram is the midpoint of the diagonals of the parallelogram. And in this figure I drew only one diagonal. You will only see why in a moment. Okay, so for now we know that O is the midpoint of DB. The question is, prove that OI, the segment, is 1/4 BA prime. And before we talk about how will we prove that OI is 1/4 BA prime, first we should know what is 1/4 BA prime. What is 1/4 of any segment? What is the quarter of any segment? And the thing is, this is how you should think of a segment. This is how you think of a fraction of a segment. Like 1/4, what is 1/4? It's you divide a segment into 4 pieces, and then you take one of these 4 pieces, right? And you have to divide the segment into 4 equal pieces, not any four pieces. And the easiest way to divide a segment into 4 is to divide it into 2, like cut it in half, and then cut each piece of these 2 pieces also in half, right? Like if you have a segment, let's say this one, and you want to divide it by 4, the first thing you do is you cut it in half, and then you cut each one of the obtaining sides also in half, and in this case you get 4 equal pieces, right guys? And this is what we're doing with BA prime. First we're gonna cut it in half at C, because C is the midpoint, and then we're gonna cut each one of these 2 obtaining sides or pieces also in half. And this way we got 4 pieces of BA prime, and OI should be one of these 4 pieces, right guys? Okay, so sorry, for now we know that OI should be 1/4 BA prime. Type. Instead of looking at it like proving that OI is a segment of BA prime, why, since all these parts of BA prime are equal, why can't we prove that OI is, let's say, half BC, for example, right? If OI is half BC, then OI is one of these 4 initial pieces, right guys? So can you prove that OI is half BC? I guess it's not hard, right? Because we started with O in the midpoint of DB, and we know from the given that I is also the midpoint of DC. So now I can prove that OI is half BC simply by applying the Mid-Segment Theorem, right guys? And that's what I did. I applied the Mid-Segment Theorem to the triangle DBC. That's why I drew only the diagonal DB. So I applied the Mid-Segment Theorem in DBC. O is the midpoint of DB, I is the midpoint of DC. So OI is parallel to BC, and OI is equal to 1/2 BC. Right guys? Okay, but this isn't the outcome I wanted. This isn't the result, the final result I wanted. I wanted OI to be 1/4 BA prime, right? And if you remember, in order to get 1/4 of a segment, we said that you should divide it by 2 and then divide each side by 2, right? So each one of these little segments, like this one, and this one, these 4, okay, these 4, each one of them is 1/4 of the segment, but each one of them is the half of the segment. Like this is the half of the segment, right? And this part in the rectangle, right guys? And each one of these tiny segments is half of this part, so it's half of the big segment, right? And that's the case in this triangle, in this exercise. Half BC, I said OI is half BC, and I want OI to be half BA prime, and this is the case. BA prime is 2 BC. BA prime makes 2 BC. So like I need to explain it. Why BA prime makes 2 BC? If you remember, C is the midpoint of BA prime, so BA prime makes 2 BC. So BC is half BA prime, and when I say OI is half BC, I'm saying that OI is half the half of BA prime. So OI is 1/4 BA prime. Okay? We go to exercise 10, page 114. Consider a triangle BEL. A and M are respectively the midpoints of BE and DL. The segments BM and LA intersects at O. R is the midpoint of BO and I is the midpoint of LO. Okay, so what did we get from all this given? The first thing is A and M are the midpoints of BE and EL. So A is the midpoint of BE and M is the midpoint of EL. The second thing is, if you connect AL and BM, they will meet at O. Okay? Plus, R is the midpoint of BO and I is the midpoint of OL. I will add the codes in a moment, and we will prove that the quadrilateral RAMI is a parallelogram. Now, before I read the answer and explain it, I want to put the codes on the figure. First, we said that A is the midpoint of BE, right? And M is the midpoint of EL. So we're putting codes, plus R is the midpoint of BO, and I is the midpoint of LO. Right, guys? Now the question is, we have to prove that this quadrilateral RAMI is a parallelogram, and the easiest way to prove that a quadrilateral is a parallelogram is to prove that it has two sides that are parallel and equal, right? And earlier in this video we mentioned that to prove that two sides are parallel, the easiest way is to prove that these two sides are parallel to the same side, right? Also said in this video that when you hear the word midpoint, you will think of the mid-segment theorem, right, guys? And then when you think of the mid-segment theorem, you want to know where to apply the mid-segment theorem, right, guys? Like here you have four midpoints, A, M, I, and R, and all of them are connected to the parallelogram RAMI, right, guys? So all these letters are in the parallelogram RAMI, so you are using all these letters. And if you look at the figure, the easiest place to spot the mid-segment theorem is the triangle BEL, like the first triangle you drew. You know that A is the midpoint, you know that M is the midpoint. So what you want to do is apply the mid-segment theorem in BEL. What happens if I apply the mid-segment theorem in BEL? What happens? If A is the midpoint, like let's read it, it's right here. If A is the midpoint of BE and M is the midpoint of EL, so AM is parallel to BL and AM would be equal to half BL, right, guys? For now we did not prove like AM parallel RI, no, AM equal RI, no, but we did use the mid-segment theorem on AM. Now can you apply the mid-segment theorem on the remaining letters that we said we are gonna use? Like we said RAMI are the letters that we want to use in the mid-segment theorems. We used AM. How about R and I? In which triangle should I apply the mid-segment theorem to use the letters R and I? Can you see it? Exactly, it's the triangle BOL. In BOL, if you apply the mid-segment theorem, knowing that R is the midpoint and I is the midpoint, what happens? Also, let's read it together. BOL. In BOL, what do you see? R midpoint of BO, I midpoint of OL. So RI is parallel to BL. You should notice something here. RI is parallel to BL plus RI is equal to half BL, and what a coincidence, guys. RI and B, or RI and AM are equal, and RI and BL are parallel because they are parallel to the same side, BL. Okay, guys? So RI parallel and equal to AM. That makes RAMI a parallelogram. Moving on to the last exercise we will show in this video, exercise 11, page 115. Let's read the given. ABCD is a rhombus. M and P and Q are respectively the midpoints of the sides AB, BC, CD, and DA. Prove that M and PQ is a rectangle. Now let's talk about the given a bit. first of all, we know that ABCD is a rhombus. That means it has 4 equal sides and perpendicular diagonals, and we know that the diagonals bisect each other at the center of the rhombus ABCD, right guys? Plus, he said that M and PQ are respectively the midpoints of the sides AB, BC, and CD. That means M is the midpoint of the segment AB, and N is the midpoint of the segment BC, etc., etc. Right, guys? Okay, so we need to prove that M and PQ is a rectangle, and if you remember, to prove that a quadrilateral is a rectangle, we first need to prove that this is a parallelogram plus something. Of course, you know that you can prove a rectangle by finding 3 right angles, but it's the hardest way to go about it, right guys? Because it's always hard to find the measure of angles, because in these exercises you don't have all the measurements. Okay, so first of all we need to prove that PMN or M and PQ is a rectangle. It means you have to prove that it's a parallelogram, then it has either equal diagonals or one right angle, right guys? Now to prove that a quadrilateral is a parallelogram, as we said a moment ago, you need to prove that it has 2 equal and parallel sides, right guys? This is the easiest way. And as I said before, to prove that 2 sides are parallel, you prove that they are parallel to the same third, and that's what happened in the previous exercise. And to find the right angle, we are going to use the nature of ABCD. Again, I remind you, ABCD is a rhombus. That means it has one right angle, which is the angle between the diagonals, the angle between AC and DB. We know that this angle is right guys? So we will try to use this angle to prove that M and PQ is a rectangle. So first of all, let's try to prove that the quadrilateral M and PQ is a parallelogram, and as I said, the way to do it is to prove that it has 2 sides that are parallel and equal. And the easiest way to do it is just to pick 2 sides and try to prove that they are parallel and equal. Alright guys? So for example, let's try to prove that QM and PN are parallel and equal. Now it looks like they are parallel, right guys? And another thing, they both look like they are parallel to one side, which is DB, right guys? This side DB, it looks that DB is parallel to both of these 2 sides, QM and PN. And if you notice, you started with M and PQ being the midpoints of these segments AB, BC, DC, and DA, right guys? And what, like, if you try to put it all together, like you want to prove that the segments are parallel, you're starting with the midpoints of this segment, so you should think of the mid-segment theorem, right guys? Because you have midpoints, you have a lots of midpoints, and you want to prove that this segment is parallel to this segment, which is the outcome of the mid-segment theorem. So first of all, you know that you're working with QM and PN, and you know that you want them to be parallel, and what you will do is try to work with each one of them in a triangle separately. Okay, so the first first let's work with QM alone. We know that Q is the midpoint of AD, we know that M is the midpoint of AB, so QM is parallel to AB and QM is equal to half AB. This is the mid-segment theorem applied in the triangle ABD. Right, guys? So if we apply the mid-segment theorem in ABD, what do we get? QM parallel to DB and QM parallel equal to half DB. If you do the same thing for PN, what happens? Of course, not in the triangle ABD. This time you will do it in the triangle BDC. Okay, so applying the mid-segment theorem in DBC, O is the midpoint of DC, N is the midpoint of BC. That gives us PN is parallel to DB and PN is equal to half DB. And of course you can see that PN is equal to half DB and QM is equal to half DB. That means PN is equal to QM, right, guys? Also, they are both parallel to DB. QM and PN are both parallel to DB. It means that they are parallel. So MN PQ is a parallelogram. Finally, guys, we need to find the right angle, and as I said, we are going to use the angle between the diagonals, which is a right angle. Okay, so what you want to do is find a right angle in the quadrilateral MNPQ. For example, let's prove that this angle is right. Okay, guys, and to do it, you are going to use the property of two lines parallel, and if one is perpendicular to one of them, it will be perpendicular to the other, right? Like you know this from grade 6. Okay, so let's start with QM and DB. You know that QM is parallel to DB from the previous part, and since AC is perpendicular to DB, then AC is also perpendicular to QM, then this angle is right. Yes, guys? Okay, plus we know that M is the midpoint of AB and N is the midpoint of BC. So by applying the mid-segment theorem on the side MN, we should get that MN is parallel to AC, right, guys? And since MN, excuse me, since AC is perpendicular to DB, so MN is also perpendicular to DB. So in this case, you get how many right angles? 1, 2, 3. So this quadrilateral right here will be a rectangle. Okay, guys? Like if you call this point O, and this point let's say L, and this one K, MLOK is a rectangle. So the angle M is a right angle. And here you go, guys, you found the right angle for the quadrilateral MNPQ. So it is a rectangle. And that's it for the video, guys. Thank you for watching.